Okay, we're gonna buzz through the first page really quickly because we actually talked about this yesterday. So if I were to take this one right here, what we learned to do yesterday is take a simple equation like this that tells you what the radius has to be. It just says the radius has to be 2. So you go 2 units and then you can turn any angle you want so that if you follow that path, it carves out a circle. Okay? What we learned to do is convert that into rectangular form. What we're going to do today is take just polar equations and graph those polar equations on the polar plane. We're not going to be worried about x's and y's or anything like that in this particular section. And we get some really cool looking graphs. So what we did yesterday is we just squared both sides. Okay? So if I had r squared equals 4, then I can change this for an x squared and a y squared equals 4. And this part looks familiar. It's a circle centered at the origin with a radius of 2. It's the same thing as going 2 units. Say we turn to an angle of 0, go 2 units, and then just continue turning around and always stay 2 units away from the pole. These two equations, this one right here in polar form and this one right here in rectangular form, both of them produce this equation right here. Okay? So you can see that this equation right here is much simpler, especially once you get used to the way polar curves work, okay, and graphing polar points and all that sort of stuff. And what I've got right here, and this is a copy of some stuff in your textbook, these graphs right here are examples of things that you can make using polar equations, okay, and these are just the simple ones, okay. You can make some really wild looking stuff using polar equations. Okay, so once we get the basics down, we'll maybe look at some that are more difficult. But this is typically what's included in a trigonometry class, in a pre-calculus class. These are typically the type of curves that you see in a first semester or in a second semester calculus class. Okay, so they've got names. So these right here, they're in a category called lemmasons. There's a little accent on there. Okay, this is a very basic lemmason. It's kind of like a circle that's smashed in on one side. Okay, this one's really smashed in. It's got a bit of a dimple. Okay, this one comes down and comes to an actual point. Okay, so that's a very basic lemmason. This one's got a little dimple in it. This one comes to a point. This one is called a cardioid. Sometimes people call that type of lemmason a cardioid. And this is called a lemmason with an inner loop. So if you take a look at the progression right here, what happens is we kind of bump this just a little bit and flatten it off. Bump it enough that we've got a little dimple. Bump it enough that we've got a little point there. Or bump it so hard we've actually got this little loop right there. Okay? And we'll be able to see how those loops are created. Okay? So those are all called lemmasons. These are called roses. And we've got a rose with 3 petals, a rose with looks like 8 petals right here. 5 petals right here, 2 petals right here, and that sort of thing. So those all come in the category of roses, and you can actually make them so that some of the petals are different shapes and different sizes. So that's kind of cool. And then we've got regular old circles, okay, as we saw right there. And then this is in a category called lemniscates, and it's kind of cool. That kind of looks like the infinity symbol. Pretty cool that there's an actual polar function that will make a graph that looks like that. And you can tilt them a little bit. You can make them go sideways. You can make them go up and down and a bunch of stuff. Okay, so polar equations are actually pretty darn cool to kind of explore and figure out how they work. These are the basic shapes that we're going to graph, and we're going to talk about the basic way that we're going to come up with these. So you don't have many of these. Okay, we talked about these yesterday. This one right here just says the radius has to be 1. Doesn't say what the angle has to be. So that means as long as you're 1 unit away from the pole, that's the curve you want. This one says you want the radius to be 2. So as long as you're 2 units away from the pole, you can turn to any angle you want, and that's the curve you get. That's the circle you get. Okay? These are very basic equations and very basic graphs. Okay? What does this one say? The radius has to be -3. So watch, please. You'll notice that on every one of these, I started right here at 0 degrees or 0 radians, and then I went in a counterclockwise direction, like we normally do from standard position. On this one, if I point towards 0 degrees, what does this say the radius should be? -3. So where should I start this one? I should start it right there. Okay? So in the exact opposite direction, okay, and I'm going to go around like that, and that's going to be the circle. Okay? Everybody good with that? By the way, it's kind of interesting to note what happens if I square both sides. I get 9, turns into a positive. And then if I wrote x squared plus y squared equals 9, wouldn't that be a circle that's centered at the origin whose radius is 3? Okay? Now, these two are the exact opposite. These didn't care what the angle was. You could make the angle anything you want. All it did was control the radius. These two just control the angle, but they don't control the radius, so you can go as far as you want in either direction. So at 45 degrees at pi fourths, I can go as far as I want that way or as far as I want that way, and that would be the line that's graphed by that equation. This is negative pi thirds. Negative pi thirds would be negative 60 degrees, so it would look like this. Okay? So if you just have an r, you've got a circle. If r equals a constant, you've got a circle. If you've just got theta, you've got a line. So if theta equals a particular angle, you just draw a line at that particular angle. Okay, are there any questions there? Easy enough? Okay, flip the page over. Let's get to something more interesting. Okay, now I'm hoping, I've got 15 minutes left. I'm hoping I can graph a couple of these. Okay, in my opinion, I would prefer that if you want to glance through the book talks about using symmetry and a bunch of stuff like that and plotting points. I'm going to show you how to plot points. I think plotting points is a pain in the butt. It's very difficult, very tedious, very time consuming. And if you make one mistake in your calculations, you're going to plot a point in the wrong place and it's going to completely screw up the graph. It's going to screw up the pattern and you're not going to be able to see what it should look like. Okay? So I'm going to show you how to plot points. Then I'm going to show you a different way that I think is much easier that helps blend the stuff that we've been learning together. Okay? And when we get all done, I'm going to show you how to do it on the calculator. Please don't use the calculator for these yet. Okay? So on a problem like this, here's what we're going to do. Okay? We're going to graph the equation r equals 3 times the sine of theta. Okay? Now, in order to do that, here's what we're going to do. Now, I'm going to work in degrees if that's okay, and then I'll switch to radians on some of these just so we're comfortable. So I'm going to put in 0 degrees. Then I'm going to put in all the common angles that I'm used to working with. So 30 degrees, 45 degrees, 60 degrees, 90 degrees, and I'm going to go that far. Okay? Now, stop for just a second and think about what that means. What that means is I'm going to point in this direction and then I'm going to figure out how far I go. Then I'm going to point at 30 degrees, then I'm going to point at 40 degrees, and I'm going to plot a point a certain distance from the pole in that direction. You with me? Okay. All I'm doing so far is I'm just going to plot the points that I get when I point in the first quadrant. Okay? So let's do this. If I plug in a 0, so gosh, stop and think back to the unit circle. Hopefully you've still got these memorized. The sine is the y coordinate on the unit circle. So it starts off at 0 and then it hits 1/2, radical 2 over 2, radical 3 over 2, and then 1. All right? So this is going to be 3 times the sine of 0. This is going to be 3 times the sine of 30 degrees. 3 times the sine of 45 degrees, 3 times the sine of 60 degrees, 3 times the sine of 90 degrees, which is 3 times 0. So that's 0. 3 times 1/2, which is 3/2. Correct? 3 times radical 2 over 2. Okay, which is 3 radical 2 over 2. Could we get a decimal for that? Three times radical 2 over 2. Should be about 1.24-ish, maybe, somewhere in there. Sorry, 2 point what? 2.12, okay? This is going to be 3 times radical 3 over 2. That's going to be about 2.598. So we'll say 6. Okay. And this is 3 times, what's the sine of 90 degrees? 1. So this is 3. Okay. You with me? Okay. This is just like you did yesterday, so all we're doing is we're plotting points. Okay. I'm going to turn to 0 degrees, and how far am I going to go? 0. So I'm right there. I'm going to turn to 30 degrees, and how far am I going to go? 1.5. So 30 degrees is right here. I end up about right there. Now, everybody listen, please. Need you to watch up here. This is a common mistake. Did it go straight from here to there? It didn't. Okay? I'm going to graph another couple points and then we'll fill in. Okay, if I turn to 45 degrees, that's a little over 2. So 45 degrees, it's right here. If I turn to 60 degrees, it's 2.6, so about right there. And by the time I get to 90 degrees, if I point to 90 degrees, I'm going to go 3 units. Okay, now, what happened is this gradually gets larger. The radius started out at 0, then it gradually got larger. It started out at 0 and gradually got to the point that it was 3 units long. So what happens is it follows more of a curve rather than going straight line. So it did something like this. With me? Okay, let's keep checking. 120, 135, 150, oops, let me make that look like a 135, and 180. Okay, think about the unit circle. Sign starts at 0 and gets big, and then it gets smaller in the exact same pattern. So this is going to be 2.6, this is going to be 2.12, this is going to be 1.5, and this is going to be 0. Is that okay? That's what it works out to be, right? If you don't believe me, throw that in your calculator. It'll work out that way. Now, so that means when I turn to 120 degrees, I go to 2.6, so about right there. When I go to 135, I go 2.12, about right there. 150, 1.5, about right there. And by the time I hit 180 degrees, by the time I'm pointing over here, the radius is 0. So again, it doesn't go in straight little line chunks. It gradually changes. The radius is getting smaller and smaller and smaller in a very gradual fashion. Everybody good there? Okay, now, if you look at the other side, there were all these different shapes and everything. So maybe this is just a circle. Maybe it's got another loop down here. Maybe something weird happens. Maybe it comes in here and makes a little loop on the inside. Maybe this is one of those lemniscates or something like that. Okay, let's check and see. Okay, we're going to plot a couple of more points. I'm going to change colors here. What would be the next convenient point to plug in? 210. Do me a favor. Grab your calculator. Type 3 times the sign of 210 into your calculator. And if you get that done, do 225 for me. What do you get? Negative 1.5. What do you get here? Negative 2.12. Okay, now stop and think about what this means. Okay, I need everybody's attention. Okay, over the weekend, I'm going to need you to try a couple of these, and I'm going to need you to think about why these work the way they do. I'm going to point at 210. So I'm going to point over here. There's 210. But the radius is negative 1.5. So which way am I actually going to go? Opposite direction. Same line, just the opposite direction. So I end up right there. Right smack dab on top of the point that I graphed when I went around the first time. Okay? When I point at 225, point at 225, the radius is negative 2.12. So I'm pointing this direction here, but I have to go in this direction over here, and I land right there. So guess what's going to happen if I go through 180 degrees to 360 degrees if I start pointing at these angles down here? I'm going to trace right over the top of it again. Okay? So this makes a circle. Okay? Okay. Watch, please. I'm going to label this point right here. This point right here is 2.12. Okay, it's actually, let's see, what was that? 3 radical 2 over 2. That's the radius, and the angle is 45 degrees. This point right here is 3 for the radius, 90 for the degrees. Okay? So there's something a little bit weird about the way you make the table versus the way you graph the points. Remember, it's always the radius first when you label a point, then the direction angle. Okay, are there any questions? Okay, you don't need to write this down, but watch. Just watch. If I multiplied both sides by r, this would be r squared, so I could write x squared plus y squared, and this would be 3 times y. And if I were to move that around, I could get that to be an equation for a circle in standard form, and it would turn out that it would have a center at about 3/2, and it would have a radius of 3/2 also. Okay? You don't have to do that. That's why I don't want you to write it down. But I do want you to know that if we change this from polar to rectangular, we get the exact same graph. Okay? Any questions? Okay. All right, let's take a look at the next one. And we've got 5 minutes to do this one. Hopefully we do this one a little, well, let's see. Tell you what, is everybody convinced that plotting points is a pain in the butt?
Yes.
Okay. Let's come down here and I'm going to show you a different way to do this. Okay? So instead of graphing this directly on here, okay, we're going to take advantage of something that I've mentioned a few times. Okay? If you have a graph, you have a picture of all the points that work in the equation. Let me say that again. If you have a graph of the equation, you have a picture of all the points that work in the equation. Well, what we did here is we listed about 10 points that work in the equation. It would be much better if we had a whole bunch of points and could produce them very quickly. So here's what I like to do. This I think is a little bit better. Okay? Let's think about how I'd graph this. And think about making this a y and making that an x. Okay? Everybody knows what a cosine looks like, right? Okay? What does the 4 do to the cosine graph? Changes the amplitude, right? What does the 2 do? Changes the period, right? So if the old period used to be 2 pi and I multiplied it by 2, I get to, remember, it's the new period is the old period divided by the period change factor. So that means the new period is pi. Is everybody good with that? So I'm going to label this. This is 0. This is pi. This is 2 pi. This is pi halves. And this is 3 pi halves. You with me? Okay, I complete a cosine curve in this much time right here. 0 to pi. And where does cosine start? Does it start above the center line or on the center line? Starts above. So we're going to go up here and we're going to put a point at about 4. And then it's going to end in exactly the same place. So remember that whole idea of beginning, middle, end, and then the quarters? It starts here, it ends here. It's going to go all the way down to -4, and then it's going to hit here and here. You with me? Okay, so it's going to do this. And the better graph you can draw, the better it's going to turn out. Wow, that looks really good. I'm impressed. You with me? Okay, then it does it again. All the way down to here, hits here, hits here. This is a more complicated graph, but I'm hoping we're going to make the polar curve pretty easily. Okay, any questions? Okay, listen very, very carefully. This is the angle we turn to. That's not proper grammar. Angle we turn to. And this is the radius. This is how far we go. Okay, so watch. So everybody got this? Okay. We're on this axis right here. What angle does this represent that we turn to? Turn to 0. How far do we go? 4. Turn to 0, go 4 units. So turn to 0, go 4 units. 1, 2, 3. Oh, I should have made a bigger graph right there. How many degrees is this? This is pi fourths, right? How far do I go if I turn to pi fourths? 0. Okay, listen very carefully again. Did it go straight from here to there? It did not. So we're going to take a little estimate so we can come up with a decent looking sketch. Okay, if this is 45 degrees or pi fourths, this would be about half of that, about 22.5 degrees. So let's follow this up here. And I would say if you turn to 22.5 degrees, we're going to need to go about, and we can ballpark this, about 2.5. Is everybody okay with that? So 22 degrees is about right there, and I'm going to go 2.5. So I'm going to go like that. So what it did is it gradually got shorter, like this. With me? What angle is this right here? Pi halves. How far do we go? -4. So I'm pointing this way, but I'm going to go down here. Now, the last point that I graphed was right here. Do I go straight from here down to here? I don't. So let's take an estimate, okay? So I'd say at that point right there, which is 3 pi eighths, or about, what would that be, 77.5 degrees or something like that, what would the radius be? About -2.5. So let's point over here, and let's go -2.5, so about right there. So we're going to go from this point to this point to this point, and we're going to do it in a nice gradual fashion. Lots of symmetry here, right? Okay. By the time we get to this angle right here, what angle is this? 3 pi fourths. By the time I get there, what's the radius? Back to 0, back to here. Did it go straight from here to there? Okay, have we established enough of a pattern? Guess what? There's going to be a point about right there. So it's going to go like this. Okay, without even finishing this, can you tell me, this is going to be a rose, isn't it? Okay? Okay, let's do this one. Okay, and I'll finish this one and then I'll let you go. Okay? If I point to, what direction is this? What angle is this? Pi. How far do I go? 4 units. So point to pi, go 4 units. Did it go from here to here? It did not. Okay, if you wanted to guess, it's going to be about right there. It's going to go like this. You with me? Okay, now stop right there and watch for just a second. Everybody watch. Okay, we went from here, around there, then like this. Guess where we keep going? Swing around here. And then we're going to make another petal. Okay? And that one's going to be around here. And then this last little bit, notice by the time I get to 2 pi, by the time I've gone all the way around the circle, how far do I need to go? I need to go 4 units. So it's going to make this. Okay? So let me just emphasize this. That's red. That's red. Okay, the homework is at the bottom of the page. I would like you to try 2 problems. Try and come up with 2 graphs, and we'll finish this section this next time. Okay? Don't do any more than 2 problems. Okay? Try to graph 2 of them. Try and make them as accurate as you can.